with exponents, you've got a base and you have the exponent. The base is the number or variable that is raised to the exponent. And once you have this base and the exponent, those two things go together, and then we can do different things to that base and exponent pair. We could raise it to a higher power, like you see here, x squared to the third power. We could multiply it times another base and exponent. We could divide by a base exponent, add another base and exponent. All these different things are called operations, which is just adding, subtracting, multiplying, dividing, or raising to a higher power. So each of these operations has its own rule when it comes to simplifying exponents. And an easy way to remember these different rules is with the hierarchy of exponents. So if you think about this hierarchy, it starts with power, but if you think about it, power, raising things to higher powers is often the last thing that you learn. And before that, you learn how to multiply, and before that, you learn how to add, and before that, there's just nothing. So here's the rule when it comes to simplifying exponents. The rule is, whatever kind of a problem you're working with, you always go one below in the hierarchy to remember what you do to the exponent. So let's look at an example of this. Let's say in our problem, we have a higher power, like x squared raised to the higher power of 3. So that's a power that we see in the problem, but now to figure out what do we do with the exponent, we go one below. So if you're looking at this exponent of 2 and this exponent of 3, and you're wondering, what do I do with that? Do I add them? Do I multiply them? Do I try to combine them somehow? Here's your answer. We go one below, and we multiply the exponent 2 times this exponent 3, giving us an answer of x to the 6. 2 times 3 is 6. Okay, well, what if our problem is a multiply kind of problem? So maybe now we have x squared times another base and exponent, like x to the third. So x squared multiplied by x to the third. So in this case, the problem is multiplication, so our rule to know what to do with the exponents is to go one below. So one below multiply is add. So now we know we need to add the exponents. 2 plus 3 is 5, so our answer is x to the 5th. Let's see, what if we have an adding kind of problem? We have x squared plus x to the third. Now our original problem has addition. When we look below, you notice now we do nothing. A really common misconception in a problem like this is to say that the answer is x to the 5th, just like in the problem before. But this time, because it's a plus in between the x squared and the x to the third, it's a different kind of problem. Now we go one below in the hierarchy, and we don't do anything to those exponents. If you think about it, these are not like terms. You got an x to the second power and then an x to the third power. Those are two different kinds of terms, so they can't be combined. So in this case, our answer is actually just x squared plus x to the third. It's already as simplified as it's going to be. Well, and this brings us to maybe a different kind of adding problem where we might have x squared plus x squared. In this case, we're still doing nothing to those exponents because it's still an adding problem, so we're still looking one down in the hierarchy. But this time, we have the same base and the same exponent, an exponent of 2. So these are like terms, so they can combine. If you think about combining like terms, our answer here would be 2x squared. So let's see how this hierarchy of exponents applies to some more interesting kinds of problems. We have our first example here of a to the 5th, b squared, a times a to the 3rd. So as you can see, we've got these three different bases and exponents. multiplied together. So our rule in this case is to add the exponents. If you think back to our hierarchy. Now, we're only going to add the exponents if the base is the same. So you see, we have different bases here. We have a base of A, a base of B, and another base of A. So the ones that are the same are the A's. So for those, we're going to combine the exponents or simplify the exponents by adding them. So we've got a to the fifth, a to the third. We're going to do 5 plus 3, which is 8. So the simplified version here is a to the 8. Now what about the b squared? That one doesn't combine with anything, so it just comes along at the end. We write those two next to each other. All right, so that's our final answer, a to the 8th, b squared. All right, this is a rule that, this is kind of an extension of the power rule, or where we see all of this stuff inside the parentheses raised to an exponent of 2. So when you see a bunch of different bases and exponents all in parentheses raised to this higher power, that higher power, in this case that exponent 2, is going to distribute to each one of those things inside the parentheses. So think about it. We've got a 5 inside the parentheses, an x to the 6 inside those parentheses, and a y to the 8th inside the parentheses. So those are 3 different things that the 2 is distributing to. So we could rewrite this as 5 squared times x to the 6th squared times y to the 8th squared. It's almost like 3 little mini problems all within this bigger problem. So now we can apply that power rule again, where we see something raised to a higher power, and our rule here is to multiply. So 5 squared is 25. That's 5 times 5. So our answer there, 25. Here we have 6 times 2, so that's 12. So it's x to the 12. And here we have 8 times 2, which is 16, so y to the 16th. And there's our final answer, okay? Now for the last example, this one is the most intense. We've got all kinds of things going on here. So what we want to do first is simplify the stuff that's inside the parentheses, because we've got these parentheses that are raised to a higher power. So like in the last problem, this exponent of 5 is going to distribute to the 2, to the x to the 3rd, and to the y to the 4th. So we could do the same kind of thing that we did before. We have 2 to the 5th, we have x to the 3rd to the 5th, and we have y to the 4th to the 5th. So it distributed to each of those 3 things, and now we can simplify. So 2 to the 5th, if you look over to the side here, that is 32, because it's 2 times itself 5 times. So that's a 32. X to the 3rd to the 5th. Once again, we are multiplying those exponents. 3 times 5 is 15. So that's x to the 15. And then again, 4 times 5 is 20. So that's y to the 20. But now that we've simplified everything inside these parentheses and we dealt with that higher power of 5, now we can also multiply by this stuff that was out in front. So out in front of all of this, we have the 4y to the 7th. So that's multiplied by all this other stuff that was inside the parentheses. So at this point, we want to see if we can combine any of these other variables or exponents. So we have, let's see, there's only one x here, so that x isn't really going to combine with anything. This 4 is a number out in front. It's a coefficient, and this 32 is also a coefficient. So we can multiply the 4 times the 32 and get 128. So by multiplying those two coefficients, the 4 and the 32, we get the 128. And then that leaves the y's. We have y to the 7th and y to the 20th. Now think about this now. It's a y to the 7th times y to the 20th. So think back to your hierarchy. What do we do when bases and exponents are multiplied? we go down 1 and add the exponents. So here's another case where we're adding 7 and 20 to get y to the 27. And then again, because that x doesn't combine with anything, we'll just write x to the 15th as part of our answer on its own.